we discussed about ARIMA, we did a most theory, and I think we started with the problem as well. Okay, so let me just continue with that. So if I ask you, tell me what do you mean by ARIMA model? Basically, what are the four different models you have in ARIMA? You have AR model. AR model is autoregressive model. What is the assumption for AR model? Yes, anybody? Okay, so the assumption for AR model is the past demand, okay, is responsible for the future demand. Okay, the future demand is a function of your past demand. And then you have something like lag. You have lag 1, lag 2. That means past 1 demand is responsible for next demand, or past 2 demands are responsible for next 1 demand, or past 3 demands, and that, and so on. So that is basically considered as a lag. Okay, lag 1, lag 2, lag 3, etc. Or remember, lag is always cumulative. You cannot have lag 3 unless you have lag 1 and lag 2 as well. Okay, so when you are using any lag, all the lags should be cumulatively significant. Then only you can use the lag for interpretation. Okay, or you can consider that lag. So that was AR part. Then you also have moving average process part. What was moving average process assumption is the future demand depends on the past error. Okay, so past error is an independent variable for the future demand. So that is the assumption for moving average part. Again, how many past errors? So if it is 1 error, it is lag 1. If 2 past 2 errors are responsible for the future demand, then it is lag is 2, and so on. For moving average part, the parameter associated is called P. Okay, so P, if I say P is equal to 1, that means moving average lag is 1. Similarly, parameter associated with moving average, for AR actually it is called P, and for moving average it is called Q. Okay, so if parameter is, you can say for AR moving average, if the lag is 1, that means Q is 1, and for autoregressive lag is 1, that means P is 1. Okay, so there are distinctive parameters. P is different, Q is different. P is for AR, Q is for autoregressive. Sorry, Q is for moving average. And then you have ARIMA model, which is autoregressive moving average model, where you have both. That means you have past demand is responsible for future demand, as well as past error is also responsible for future demand. So in that case, what we consider combination of P and Q. Okay, so you have a moving ARIMA model which has P and Q as the parameter. P for autoregressive part, Q for moving average part. Now, all these three models, the assumption is the series is stationary. If the series is non-stationary, then you have to make the series stationary, and for that, then one of the ways of doing it is basically differentiation. Okay, differences. So when you do difference, then that is called as ARIMA model. That is autoregressive integrated moving average model. Okay, so integrated moving average model has 3 parameters. P is for lag of AR model. Then Q is for lag.
Hello. I don't know about others, but I'm not able to see anything.
No, I am not doing anything. I'm just explaining. I'm just revising the previous part. Okay, then I will do the problem. Okay. So for Q, I was just talking about, see, ultimately at the end of the day, you want to find out ARIMA, P, D, and Q. So if I know the values of P, D, and Q for ARIMA model, that is my problem is solved. Okay, I want the best values for P, D, and Q. P is for, you can say, lag of AR model. Q is lag for moving average model, and D is the difference, how much difference you are doing. Okay, so once these 3 parameters are done, that means you have solved the problem. So let's do this same thing. Let me just open the data. I have not yet opened the data. In fact, I had closed the data because I wanted to open it. Okay. So this is, I think, did we do this last lecture? I think we did it. So you have serial number and breakfast. This is basically for a hospital monthly breakfast, let's say for monthly breakfast for idli, and how much is the demand, and 30 days demand is there, and you want to calculate for next 1 week demand. Okay, so you can use analyze. So how do you know what is what? There are thumb rules. Of course, they are very much basic thumb rules. Sometimes you cannot, none of the rule really tells you, gives you any proper indication. And then you would generally use a trial and error method. Okay. So first, let me just explain you the thumb rules. So what you use is the autocorrelations, and the functions are ACF and PACF functions. So I'm just using breakfast as variable, and then you can see this is your ACF and PACF function, generally gives you the indication. Okay. So what exactly what you look here is, first what you look is this decreasing properly or not? Okay, if it is decreasing very slowly, your ACF function, that can indicate the presence of non-stationarity. Okay, so this at least doesn't have this presence of non-stationarity, and generally partial ACF function gives you value of P. Okay, so if this, you can see here, this particular most of this data is within this, but the first one is beyond this. That means if I take P is equal to 1, that could be a good model at this stage. Okay, so this partial ACF generally gives you the value of P, the best value of P. There are certain rules, as I said, we will see that, we'll see, check the different rules for ACF and PACF function. But along with that, there are certain rules you need to follow, which uh, basic rules, I would say. The lesser is the number of parameter, better is the model. Okay, so you don't want to really overfit by using too many parameters. So the minimum values of P, Q, and D are most desirable. So lesser the value of P, D, and Q, better is the model. So that is one main important thing you'll have to keep in mind. And then there are, of course, another parameters like normalized BIC, and then you have LB test, etc. Okay, so we'll just, let me just do a forecast here. So analyze, forecasting, and I'm just going to click on create traditional model. Now by default instance, SPSS, it gives you something called expert modeler. Now this expert modeler, yes, it's supposed to give you the best model. Okay, so it will actually try different models and will give you the best models. Sometimes it works, it does give you a best model, and sometimes it doesn't work. Okay, why? Because it only optimizes model on the basis of BIC. Okay, normalized BIC. It doesn't look for the other requirements, which also are very important. So sometimes if your expert modeler gives you a best model, and that best model has all the other requirements correct, then you should just go ahead with the best model. Okay, so you can always try expert modeler first, and if it gives you right model, it's not a problem. But if it doesn't, then you will have to do manually whatever number of whatever parameters tuning you need to do, you need to do manually. Okay, so presently I'm not using expert model, I'll use it at the end. So I'm just clicking on this and using ARIMA. Okay, I want to do ARIMA model. And when I say ARIMA, I have to specify the criteria. So what I said was, let us take p-value as 1. Okay, because that's the simplest thing to have. And we also seen that PACF had one, you can say, one period which was beyond the line. So that generally indicates p equal to 1 as the proper criteria. Okay, so I'm just picking p as 1 here and do continue. Then I can also select statistics. I want residue this, also want to display the forecast, and I need all these parameter estimates, and of course this fit measures. Okay, main important is normalized BIC. Okay, because when I want to compare different models, I would compare it on the basis of normalized BIC. Now this normalized BIC you can consider very similar to adjusted R-square. Tell me, what was the difference between R-square and adjusted R-square? What was what happened in R square and adjusted R square? Whenever you added new variable, your R square increased, but adjusted R square only will increase if the added variable added value, okay, or if it is important. So that's the difference between R square and adjusted R square. Similarly, when you consider any of these criteria like R square or root mean square error or MAPE, okay, forget R square and this root mean square error or MAPE should be as low as possible, okay. So any model which gives you minimum MAPE is supposed to be good, but sometimes it may happen that your model is giving minimum MAPE, but it is overfitting, and that is exactly why you check normalized BIC, okay. So it may happen that the added parameter is reducing your training value or training you can say error, okay. MAPE is basically your training error, but it may increase your testing error, okay. So that is what normalized BIC checks, the number of basically the overfitting, the level of overfitting. So it will only keep the parameter if the parameter supposed to be important, or in short, if added parameter is not useful, your normalized BIC will increase. Okay, if it is useful, then the normalized BIC will be decreased. So it's opposite of adjusted R square actually. So higher adjusted R square is better, but lower normalized BIC is better. So when you compare two models, you look for minimum normalized BIC. Okay, the two models, whichever has minimum normalized BIC is supposed to be a better model. Okay, similarly, when you use for regression, the maximum adjusted R square was supposed to be a better model. Here, minimum normalized BIC is a you can say consideration for a best model. The other criteria go in a little bit backstage because they can give you overfitting. But normalized BIC avoids the overfitting. So lesser BIC means better model, as straightforward. Similarly, you also need plots. You can just select this fit for plots plus confidence intervals, etc. The main important plots are these two plots. Okay, the error should be within the limit. So that is another requirement which you need to check. Rest is fine. Okay, so what I did was just took the variable in criteria. I just used, because if you remember, we had done ACF, PACF charts, and then PACF was only one period was more beyond that line. That's why we took as one as the criteria here. And in statistics, I picked up all this here plus normalized BIC and this criteria. In plots, we need this and this. Other plots are not really necessary. Okay. If you have any filters, etc., you can do it later on. But presently, I'm just going to do okay here. So it's okay. What has happened? ARIMA 000, something went wrong. Forecasting. Okay, so criteria. Okay, so as I said, 100. That is what we are looking for. Okay, let me still again check this. Criteria is 100. Fine. Then statistics. These are there. Plots. These two are necessary, and these one are also fine. And that's it. Okay, and just do okay. So this is your ARIMA 100 model. Okay, always check with this. And this is your fit statistics. Okay, fit statistics is how good is the model. So you can just say, okay, ARIMA 100 model has, let's say, normalized BIC 3.498. Then MAPE is 10.518. Okay, I have noted this down. So now if you see by itself, you can't understand anything or you can't conclude anything. But if you want to compare with another model, yes, these are very useful values. So the next what you look at is this R square value. Again, it's you can't do much about this R square value, but yes, this LB test should not be significant. Okay, so that means significant value should be more than 0.05. So that's another parameter, another requirement. This test should not be significant. Then the next parameter, next requirement is whatever lag you are using, it should be significant. Okay, so here because we have used lag 1, it has only one coefficient and it is significant. Constant, not necessarily significant, but every lag should be significant. And the next requirement is this data should be within this errors. Basically, these are ACF residue and PACF residue should be within this two lines. This is very, very important. If this doesn't happen, then you may have to change the parameters and check if any other model is making it better or not. Okay, and this is exactly why this is the reason why you can't only depend on expert modeler, because it may give a model which has minimum normalized PIC, but it may not do the other requirements check. Okay, it may not make sure that the errors are within the limit. So that is not really a acceptable model if the errors are not within the limit. But this looks okay. Okay, so but you can do a little bit difference here, or let's try different thing. So I can again do analyze forecast, create traditional model. In criteria, you can see here there are some transformations it allows you directly. So I can just do square root transformation. Okay, so let's see whether if I do square root, is it giving me better results or is it giving me worse result. So I already noted down normalized BIC and MAPE. Okay, so let's continue here, do okay. So start with, again it's the same model, ARIMA 100, except that now we have taken root of demand as the independent variable. Okay, so you can see what is your value of MAPE, 10.447. It was 10.518. Okay, so that is reduced, but that is not the best thing. The most important thing is normalized BIC. Is normalized BIC reduced? The new normalized BIC is 3.500. Okay, and the previous one was 3.498. So it's not reduced. In fact, it is increased slightly, but it is increased. So that's not really desirable. But let's still check the other things. You can see that yes, this LB test is not significant, which is correct. Then you can also see that the each and every lag, it's only one lag in this case, is significant, which is fine. And the errors are also within the two lines. Okay, so this also decent, but it's not better than the previous because it doesn't have a lesser normalized PIC than the previous. Okay, as I said, like you use adjusted R square as the parameter to consider the best model among many models. Here you will consider normalized BIC as a parameter to consider the best model among all other models. Okay, so let us do other one. Let's say whether if I do same criteria, let's say natural log, if I consider, is it going to be better? So let's say MAPE is 10.377, okay, which is lesser of course than your normal model. First model had 10.518, 10.377 MAPE is surely less, but normalized BIC is 3.504. Okay, so which is actually more than your original first model, which was 3.498. So it's not really a better preferred over the first model. Okay, so still we'll check rest of the things. Significance, it is not significant, which is fine. This is significant, which is fine, and errors are within the limit. Okay, so yes, everything else is fine, but BIC is not the best for this particular model. So I would say that if I have to consider ARIMA as the model, I would say the first model was the best. Now, if you ask me, okay, suppose if I don't understand from AIC, BIC, anything, okay, then how do I go ahead? Simple, you have to try all possible combinations, okay, and you will always try with, of course, 1, 0, 0, okay. Differences you don't do unless there is a non-stationarity, okay. Non-stationarity is very clear, you can very easily understand if the series is stationary or non-stationary, and that can give you very clear cut understanding about stationarity. Okay, so D is never taken randomly. Okay, D is only used when it is necessary, but P and Q parameters can be considered randomly. Okay, so if I consider, okay, let me just make P value as 0, suppose, because the other simplest form is P0 and Q1. Okay, so let's see whether this is giving me a good model, and let me take a normal one, because the normal one only was better in the previous case. So this is another model which I may consider and see whether this is working fine or not. So 0, 0, 1, that means P is 0, D is 0, and Q is 1. That means I'm assuming that only previous error is responsible for the future demand. So this is ARIMA 001. You can see MAP has increased to 11.630. So MAP is higher. What happens to BIC? Normalized BIC is 3.664 and our best was 3.498. So it's not better than the previous. Okay. And if you say yes, moving average, it has significant, even though this LB test is not significant, which is what it should be. This should not be significant, and this coefficient should be significant. So far so good. Okay, and okay, these errors are also within the limit. Okay, it's touching, but yes, still within the limit. It's not crossing the line. So I could have taken this as the best solution if this had lowest BIC. Unfortunately, it doesn't have lowest normalized BIC. So this cannot be a better solution. Okay. And then again, our rule says that the simplest is the best model. So there is no point going further. Okay. I will not do 101 because 101 is obviously more complicated than 100 or 001. Yes, Nitin?
Ma'am, so since this is a ARIMA model, so we will not do any outlier analysis, right? Because the data is with date wise, so that data will be removed. So
yeah, you don't do outlier analysis, but you can identify outliers here as well. So it allows you to do it within the ARIMA.
okay.
Okay, so you can actually detect outliers and remove, because many times you do have outliers. So you may have certain days where you have very high or very low demand. So it can consider them as an outlier and it will do it automatically. But you will not do other Cook's distance outlier.
Ma'am, can you go to the outlier tab once? Like what is the, okay,
Yes,
do not detect outlier, detect outlier. Okay, yes, ma'am.
okay, so you can directly detect the outliers and do the analysis. Okay, so what I said was, because simple principles you take, it will not be too complicated, because you want a simplest model as possible. If a simple model is decent, you will not go for more complicated model. Now what happens if I do complicated? Let's see. Okay, if I just make this 2. Okay, if I'm taking ARIMA with P is equal to 2. Actually, my best model was P is equal to 1. So what will happen? Any guesses? Obviously your normalized BIC is going to be higher, okay, because that means you are actually trying to overfit. Okay, may be less or more, that's a different case, but your normalized BIC, because remember that is automatically a measure of overfitting. Okay, so unnecessary parameters you take, it will automatically overfit. Your best model was 3.498, and obviously this is more than that. And another problem, this is fine, this is not significant. Can you see another problem here? The second lag is not significant. So even if it would have given you, of course it would not give you, because the significance has direct relationship with the normalized BIC, but this is not a significant model and I cannot use this model. Why? Because lag 2 is not significant. Are you getting this? So this cannot be used because lag 2 is not significant. Rest all is fine. Okay, but lag 2 is not significant, and obviously the most important thing is normalized BIC is not minimum. Okay, so then the model which we considered first seems to be a best model in this case. I would say one.
Ma'am, could you try the 101 model and show us what the difference is in terms of complexity? Because both one in Q and one in P were giving a good model, right?
Yes. Okay, so if I took 101, again your normalized BIC will be higher. Because you're unnecessarily adding one more variable. Okay, and let's say significance, the MA lag is not significant. So this significance has direct relationship with this BIC. The more insignificant variables you add, your BIC will increase and it will not be optimal. The lesser the BIC, more optimal and more accurate is the model. Okay, so you can't, this is not a good model here because what is happening is now two things. One is this is not significant. Okay, this second the moving average lag one is not significant. And the second thing is this normalized BIC is not best. Okay, the minimum we found so far was 3.498. Okay, so I could actually use, let me just go back there. So this will not work because it is not the best model. Okay, so suppose if I say this is my best model so far, and I can also do, once I decide this is best model, I can save the forecast and lower and upper confidence limit for this, and I can just do okay. And what will happen is wherever there was blank, you remember you wanted to predict for next 7 days or 1 week, it will give you the forecast for the next 1 week. Okay, if there were 100 blanks, it will give you the forecast for next 100 blanks. Okay, so ARIMA model is a long-term forecast model. It's not a short-term. You could just forecast as many number of future observations using this. Of course, it will be more accurate if you are not forecasting too many. Okay, that is always there, but you could always do it. So you can also use this as a test set if you have kept this value somewhere else, and you can actually test these values and find out the difference and find out how accurate is your forecast. Okay, now one more thing, let me explain it to you. You can also try expert modeler because it has every software has it basically. Every proprietary software, even SAS has similar kind of things. As I said, sometimes it gives you good results, sometimes it may not give you good results. Let us try in this case. So I'm just using expert model. It will use all the models. Even it will use smoothing models as well. Exponential smoothing models also it will use. Whichever is the best, it will take that. And the best is considered on the basis of BIC. Whichever has minimum BIC will be considered as a best model. So I'm just using, once I'm using expert model, I'm not using criteria. It will just do all the models. And now you can see, as I said, what is a normalized BIC? 3.179. Okay, do you agree that it is lesser than your previous best BIC, which is 3.498? Okay, so, and if you see here, it's a simple exponential smoothing model. Okay, that means alpha, not even double exponential smoothing or triple, but just simple exponential smoothing model. Again, this LB test is not significant, which is fine. Then you can see the alpha, whichever you have, but the value is 0.655. You have done exponential smoothing. You should understand this, and it is significant. And you can see both AIC, ACF and PACF functions are within the limit. Okay, so in this case, yes, this model seems to be a good model, and it also is giving you minimum normalized BIC and of course minimum MAPE as well. Okay, can you see?
Ma'am,
Even the MAPE is lesser. Yes.
ma'am, but like in this case, when like can we use this model, because you were like do it also depend on what our objective is, because you were mentioning in the last class that the exponential smoothing model are short term and ARIMA models are long term. If we have test data also.
Yes, exponential smoothing model is short term, but what happens is it uses your previous, it has a way of doing long term. For example, if I do here forecast saving, okay, it is already saved. So you should know that it will do it for the long term as well. You can see here it has actually calculated it. No, but it has calculated same value because it's a short term. Yes.
Yes, ma'am.
That
That's
is a problem. That is a
yeah.
problem. Yeah. So Yes, that is another thing, that if you want to really
Ma'am,
do,
I think it depends on what our objective is.
yes,
So
yes,
that's
that's you got it exactly right. Okay, because unfortunately, exponential smoothing doesn't give you more than one term next. Okay, because the way the formula is, it can just give you the one next term. So what it will do is, it will assume everything same. That's very pathetic actually. So it's just giving you a fictitious kind of best model. Okay, but that's fine. But still, at least if you have a looking for a short term forecast, you can still use it. But for a long term forecast, you may not really use it. Okay, so remember that whenever you are using exponential smoothing, it always has that disadvantage. Okay, is this fine? Yes,
yes, ma'am.
Raghav.
Ma'am, two questions. One was how do we decide, like, suppose if I have 10 years of data and I want to use that to predict further, there will be a change in customer behavior and maybe the buying pattern and so how do I decide that what period is correct, like should I take 10 years, 9 years, or only 3 years to actually predict my model, to actually put it as the data in my ARIMA model?
Okay, when you're saying change in the consumer behavior, what kind of change you're looking for? Because generally, remember, all these changes which happen automatic, they are slow changes, and if you are using all the data, you get to that. I mean, the pattern will be visible automatically. Okay, so like for example, you are talking about a ketchup from a spicy no, bland one to spicy one. Change is not going to happen drastically. It is going to happen over the period of time, and then pattern will automatically let you know, and ARIMA will pick it. But if there are certain events which, like COVID kind of things, which have a sudden change, then it is a problem. Most of the
Okay, ma'am.
change happens gradually. Okay, unless there are some changes which do not happen gradually, then it will not be able to pick. But otherwise, most changes, it should be able to pick it. So though you are taking old data, you're not giving. See, that's the problem with the exponential smoothing. If you remember, we did the disadvantages of exponential smoothing, that exponential smoothing has a lot of baggage of old data, but ARIMA doesn't. Okay, so though you may take last 20 years data, it will still use on the basis of your latest data.
Yes, ma'am. Ma'am, for example, I was saying when Maggie was stuck in the lead scam, at that point in time, if you took data for say 10 years, you would see a major drop down in that 1 year or in that in those few
Then that
months.
is an outlier.
So,
That will be automatically identified as an outlier if you tick on that outlier thing.
and does the model then remove that or disregard that while
Yes,
calculating
yes,
the
yes,
forecast?
yes, yes. That is what exactly outlier analysis will do now.
Ma'am, just one more question. How do we use dependent variables in this, and what kind of variables can come independent?
Any dependent variable. So you can add, because many times your demand is the function of past as well as other things. Can you say independent variables?
Yes, ma'am. That's what I'm saying. What kind of variables can we put in
Like for
independent variables?
example, this is about demand. Okay, so let's say maybe month could be, or one of the independent variable could be obviously number of people in the hospital, because on a given day how many people are there in the hospital, that also will determine what will be the breakfast now.
Yes, ma'am.
Okay, so if you are talking about a normal demand forecasting, then price of the product, then advertising expenses, all that could determine demand, that could also be the independent variables. In fact, it
And
also gives you something like event. You can determine an event actually here. Okay, so if you can actually determine an event. So there is difference between event and independent variable. Event is a uh, kind of qualitative thing, which is like COVID could be an event. You understand? So you can determine an
yes,
event
ma'am.
also here. So you can give a independent variable as well as you can define event,
So,
and
ma'am,
then
does
it
it
will give
also
it.
give us, like how in regression when we do a stepwise or we do even the enter regression, we actually come to know if the variable is significant or not?
Yes,
Does
it
this
does that.
also give us
It
a
does that.
okay?
Yes. it will only keep the significant ones actually.
Okay, thank you, ma'am.
Yeah. Okay, so I think this one is clear. Let us get the second question, second one. So we'll just do three problems given here. ARIMA problem 2. Again, same logic. Go to analyze, forecasting, just do autocorrelations and see what is the autocorrelation function looks like. As I said, there is ACF function, there is PACF function. Now, PACF function generally gives you the value of P, okay? And you can see it is decreasing properly, okay? It's not actually decreasing slowly. So you can say there is no stationarity again. And looking at PACF, you can say that P value could be 1 because only 1 is beyond this two lines. And if I look at ACF, you can see it is crossing two values. Third one is just marginal. So I can consider Q value as 2. Okay, so ACF gives you Q and PACF gives you P value. So Q can be 2, P can be 1. Okay. And of course, because there is no problem of stationarity, there is no need of D. Okay, so that is a, you can say, thumb rule. Many times you can't really understand using a thumb rule, frankly speaking. I mean, when I have done it for many times, it's not necessary every time you can really understand using thumb rule. So I'm just going to use ARIMA criteria. Now, as I said, the P value was given to be 1 because PACF was crossed, beyond the line only 1 period. And for ACF, it was 2 period. That's why Q value is 2. Okay, so that is what is the thumb rule says. And similarly, I'm just going to do the same thing. Select all these things plus maybe R square, mean square error, mean absolute. In plots, forecasting plots, and the main important thing, residue plots. And saving I'm not going to do now. Okay, once we find out the best model, then we will do the saving and do OK. Okay, so this is ARIMA 1, 0, 2. P is 1, D is 0, Q is 2. And let us write down what is normalized BIC here. 9.640. Then MAP is 14.231. Okay. So let's see whether everything is fine. So we start with this. LB test should not be significant. That means significance should be more than 0.05. Then all lags or the coefficients should be significant, which are there except constant. Constant not necessary, but other than constant, everything should be significant. You can see they are significant. And the third requirement is this should be within the range. Okay. So all three requirements are fine. So this seems to be a good model. Now you'll ask me that why we directly did this. Okay, because suppose if I can't understand using, the logic of that ACF and PACF. So generally what you do, you start with 100. Okay, so you can just go step by step. Start with 100, see what is happening. Okay, so normalized BIC is 9.636, actually lesser, so it's not a problem actually. If everything else is fine in this case, this is also fine. Okay, but can you say this is a acceptable model? Because this error is beyond this, so you cannot take this model. Do you agree? It's not only about normalized BIC. All requirements should be there. What all requirements? As less as BIC possible. Then this should not be significant, LB test. All the coefficients should be significant. And main thing is this error should be within the range. And you can see very easily at least one error is beyond the range. This is not correct. So I need to do something else. Let's try another model. I'll just do forecasting and criteria. Okay, so let me try 101. Okay, see whether this will work fine. Again, this is ARIMA 101 because as I said, the simpler model is much better, much accepted than the other one. Here the normalized BIC is gone high, 9.722. Okay, our original BIC was 9.640. So, okay, BIC wise, this is bad. Let's see anything else. Can I take this? Is it significant? This is fine. This is not significant. But is this significant here? Lag
Yes.
1?
No,
Lag
ma'am.
1 is not
We
significant.
cannot take it.
We
Yeah,
cannot
is
take
not.
it because not significant. And you can also see that again, we can't take this again because this is beyond the limit. Okay, so this is not acceptable. So let's go back and so you can try all, okay, and you will find out that ultimately you will get that model as a simplest model. Let's try P is equal to 2 instead of Q is equal to 2. Okay, so that's only one combination left. And let's do okay here. So again, normalized BIC is very high. So even if everything else is fine, you can't take it. And you can see very clearly, this is not significant, this is not significant. Okay. And this is also not within the range. So what I'm trying to say is, even if you do trial and error, you would still land in the same way. Okay, so then I'll consider the next simplest model is 1, 0, 2. Okay, which is what our model was. And if you consider this, then this was our normalized BIC. Then, okay, this was not significant. All these lags are significant and the errors are within the limit. Okay, and anything more you should not take because the lesser this one. See, as far as all the errors are within the range, you don't need to go more complicated model. Okay, the simpler model is always best if it has all the requirements satisfied. Now, the only thing we could do more is maybe try square root or log. Okay, so I'm just trying square root here to see whether any transformation works. So I'm just going to write it down. The new MAPE is 14.199 and normalized BIC is 9.652. Okay, your original was 9.640 and now it is 9.652. Is it better than previous? Previous one was 9.642. The lesser
No,
is
ma'am.
better. Okay, so again it is not good. But still, let's check everything else is fine. Everything else looks to be fine, but not better because the BIC is not lowest here. So let's try the last option here. So let's see whether natural log works. So 9.671, again higher BIC. So again, this is not going to work. Okay, though everything else looks to be fine here within the range, within the requirement, basically. But still, this is not the best model. So the previous one only is the best model. Okay, so I would say now let's try expert modeler. Okay, so let's try expert modeler, forecasting, create models, and see whether expert modeler is giving you better result or not. Okay, so again, it has given simple exponential smoothing. So you already know one drawback of simple exponential smoothing, that it cannot be used for long-term forecast. But yes, it has minimum normalized PIC, which is 9.519, where ours was best was 9.640. Okay, so that way it is better. This is significant, which is fine, but still you can't take it because this also is not correct. Okay, even for a short-term forecast, you will not take it because error is not within the range. Okay, so what I'm trying to say is the expert modeler is not the best in SPSS. Okay, it only gives you, it will try all the models and pick up the one which has minimum normalized PIC, which may not be really a good criteria because there are more than that requirements for a model to be a good model. Okay, so just because expert modeler gives you a model doesn't mean that it is a good model. Is this part clear? So I will not take this as well. And let me just go to forecasting. Rest all let be ARIMA. This, and don't want natural log as well. So 102 seems to be the best. And let's do save because this is our final model. So once you decide the final model, then you can actually do the save for that. And you can see it is, calculated for the rest of the data. Okay, so whatever is missing, it will calculate for that as a forecast. Is this clear?
Yes.
So now only one more left, which is non-stationary file. Okay, when your data is non-stationary. So ARIMA problem 3, that gives you non-stationary data. Again, this is like same hospital problem, but now you have demand for omelette as a breakfast, and you want to forecast for next, I think, 18 periods. Okay. So again, same logic, you will use forecasting, autocorrelation, put omelette here, do OK. And now you can see, is it decreasing normally? No, it is decreasing in a very slow manner. This is the indication of, you can say, non-stationarity. Okay, so there is, when your ACF is decreasing very slowly, that indicates the presence of non-stationarity. Then you need to take care of the non-stationarity. And what do you mean by take care? By doing differencing. So what I'll do is analyze forecasting, autocorrelation. You can also use a difference here, one difference, and then say OK. And now you can see it is now proper. Okay, it is decreasing rapidly, and that's how it could be useful. And if I use another rule also, you can see for PACF, it is crossing one value here. Okay, it's just crossing only one, that means one period. That means P is equal to 1. And for ACF, again, it is only crossing 1. So Q is equal to 1 and D is already 1. So P equal to Q is equal to D, that is 1, 1, 1 could be our better model. So let's say, let's try that ARIMA model. Analyze, forecasting, create traditional model, select this, then use ARIMA, use criteria. As I said, 1, 1, 1. Now here only fixed thing is one middle. Okay, and you can try other options. Okay, why one is fixed middle? Because you have to do difference to make it stationary. Then only other you can try other options. Okay, so this D is going to be one fixed. Then you can try this 0, 1, 0. Oh, sorry, 0, 1, 1 or 1, 1, 0. These are the other two options you can try. Again, statistics. Select this, select normalized PIC. In the plots, name these two plots and other plots. Okay, just to, so you can say, let me just write down, your normalized PIC is 2.577 and MAP is 20.188. Okay. Then this is not significant, which is fine. Then you can see all of them, both the lags are significant, which is again fine. And you can see both, all the errors are within the range, which is also fine. Okay, so all these three requirements are okay. So this seems to be a okay model. So you want to check any other model, we can use different parameters. As I said, if I have to check, I will check for a simpler model. Okay, because the more simpler is the model, the better is the model. So if I just make 0, 1, 1 as one of the another options of the model for checking, I would say now may normalized BIC is 2.555. So actually, if everything else is fine, this is going to be a better model because your previous normalized BIC was 2.577. So 555 is obviously lesser than 2.577. Okay, so let's see everything fine or not. This is not significant, which is fine. Lag is significant, which is fine. Okay, but if you can see, this is like almost crossing this line. Okay, this is almost touching, but this is crossing this line. Can you see? So this is a problem over here. Okay, because this is not going to be, this is fine because you can see there's still small gap over here, but this is touching. Okay, so that's not really accepted here. That is why this cannot be considered as a better model. Similarly, I can try another option. I can make this as 1 and this as 0, which is another simpler model. Remember, the moment you make model simple, your BIC will decrease because that's exactly what it is. Okay, so now your value is 2.579. Okay, but unfortunately it is not lesser than the previous one. Our best was 2.577. So slightly more than the first model which we checked. But still we'll see this is not significant, which is fine. This is significant, which is also fine. And here also same problem. Okay, so that means you need to have the other model exactly. It's almost, see, because unfortunately this line is so thick that you can't understand, but you can see that this could be fine. These are all fine, but this is almost like touching and crossing. We can't really make out, but because it's very small, but it is not acceptable again. So you can say the model with, so the logic is very simple. The simplest model which satisfies all requirements is supposed to be the best model. Okay, so you can say this was our model which we considered. You can see now everything is properly within the two lines. Only thing what you can check is whether it is, log is good or not. That you can always check on the basis of BIC and other requirements. But is the process clear? So you can actually check if you don't understand by using ACF and PACF function. Okay, you can still use trial and error method using a simple logic that the simplest model is the best model. Okay, so if a simpler model is a good fit, then you don't try for more complicated models. If you use that rule, I think it should not be too much difficult for you to find out the values of P, D, and Q. And if you find out the values of P, D, and Q, your problem is solved. Then you can actually use that and get the ARIMA model. Is this clear? Any questions? You could also do the forecast for here. So suppose if I use this as my final model, I can just say save forecast. Okay, and then remember, even if there are like 100 observations, it will do the forecast for you. And because it's using ARIMA, it will give you different forecasts for different periods according to that. Okay, so this is your forecast. And this is the 95% confidence level for the forecast. And can you note something? Can you notice something here? What is happening to the 95% confidence interval? Can you observe?
It's decreasing.
What is decreasing?
The lower limit is
range is widening.
So as you are going further, your 95% confidence interval range is becoming wider and wider. Okay, so that means your accuracy is highest in the, remember what I told you, 95% confidence interval is always the validity of your point estimate. Okay, more is the width of the 95% confidence interval, less valid is your point estimate. Okay, so that way technically you can make 100 forecasts, but it will become wider and wider and wider the more you do the forecast on the basis of the very old values. Okay, so it actually tells you, you can see how the forecast is, it's not on the basis of value. Okay, because this is you can say 17 and 19 is not too much difference. It's not on the basis of value, it's on the basis of period. The further you are going from this one, the more is the width, which is obvious, isn't it? Because when in a time series, you are actually trying to find out too long interval for forecast. Okay, the longer forecast you find, the less accurate it is going to be. Okay, the more standard error it is going to have. Is this clear? And somewhere this same phenomena you will get in graphs as well. See, can you see here how the graph, this is your 95% confidence interval graph for the forecast. Okay, so this is your forecast and this is your confidence interval. And you can see it is widening like this. You can see the pattern of it. It is going to be more and more like this. Okay, any questions on this? If there are no much questions, I can go to, let me stop sharing the screen. Let me also stop